So what we'll do now is we'll construct a normal probability plot using two different variables, one from our mutual funds data and the other from our undergrad survey data, the wealth variable and the 3-year return variable. So I'm just going to open my chapter 6 demonstration file here, and I want to go to my undergrad survey and take the wealth data, paste it here, and I don't need my header. So the first thing we need to do is to rank these numbers. Okay, so maybe it's better if we actually use this. Okay, so I need to create a rank from that, and but before that I need to sort it. Uh, okay, so the data here have been sorted from lowest to highest. So we have here considering $100 million as the amount of money that would be required to consider yourself wealthy. And we have here many people actually considering 100,000, 500,000, and etc. So we just need to provide rank numbers, start with the lowest. So you can just use copy and paste, just expand the selection. So we have 62 values, so that's the rank. Now, each rank can be turned into a percentile. And there are different formulas for this, but I'll use rank divided by n plus 1. N plus 1 here is 63, basically. Okay, and I'll use this percentile. Okay, goes all the way up to 0.98. And in the middle, if this is even numbered, I should have 0.50 exactly. If not, I will have two values above and below. So now we can find the z. Sorry about that. Okay, I think that's good. So now let's get the z. Okay, and for this I need to use the norm dot s dot in function, and I will use the percentile. So this will give me the z. Okay. Okay, so now this would be enough for me to construct the z table. I just want to drag this over here one more time. Okay, and I want to now just insert a scatter plot, and let's make it slightly bigger, and I'll get rid of that. Okay, so now you can see there is a shape here which is associated with heavily right skewed data. So normally we have to have a straight line going up like this, but we have a probability plot that has a curvature. Okay, so we can also see the same thing. Remember, previously we did a histogram of the wealth data, and the histogram will confirm our expectations. So let me do one more, which looks more like a normal distribution. From the mutual funds, let's take the 3-year return. Okay, so let's paste it over here. Now, similar situation, let's calculate rank. Let's calculate percentile and z. And so I think now we have more. Wait a minute, let's first do a sort. from lowest to highest. Then let's continue with the ranking. So 869. So conversion to percentile, 868 plus 1. And let me just do the norms inverse. Okay, and let me paste them both together at the same time. Okay, and let me get the 3-year return one more time to here. And just use my scatter plot. Okay, I think now you see the difference between the two. Well, this is pretty much a straight line, with the exceptions of a few outlying points. All right, it's more or less a straight line in the middle. I mean, considering probably 850 of the stocks, mutual funds. So just a few, 5 here and 6 there, that actually don't conform to a normal distribution. So this is the normal probability plot. Something else you can do is to find the correlations between the z's and the x's. So I can do that maybe with D and E, and it should be quite high. As you see, 98, so mostly linear. On the other hand, if you come to here with the wealth data, and again, okay, this is quite low, 0.59. So heavily right skewed data, normal probability plot versus pretty much normal with a few exception, with a few outlying observations with the 3-year returns data. And in the future, of course, we will also consider some hypothesis tests checking for normality. So I'm going to put this file, chapter 6 demo, it's complete now, on my website for you. So you might actually take a look. So this will actually conclude the last of the videos I'll be recording for this semester, covering the normal probability plot.